Hi again. I'm Tamsin. I realized that I didn't do a self description. So hi, I'm a person with a mustache and long hair, with a little salt and pepper. And the ghost that you do not see beside me is Matt Critchlow. Unfortunately, I understand Matt is sick today, so this is wishing health to him and his family. This was going to be a bit of a Abbott and Costello routine, where I tell you all the good things about Project Surfliner's monorepo strategy, and Matt tells you the sticking points and downsides. And so if what you end up with is a slightly rosy colored view of this, then I apologize. Press me during Q&A. I've also enlisted Jessica Hilt to hop in Q&A and help me out with interpretations that might be less than my particular happy view of how this has all gone. That's also my revenge to Jessica for the title of this the title of this talk, which I'm pretty sure she picked. So she
The
did
best
pick it.
title ever, you mean?
I think she did it to embarrass me, but I'm not embarrassed. So here we go. Let me start by telling you a little bit about Project Surfliner. So Project Surfliner is a collaborative project between the UC Santa Barbara and UC San Diego. We do have some interest from some other UC campuses. It's really scoped as UC internal collaborative digital library development. A phrase we use regularly is the collaboration is the project. So that may be familiar to some folks from a Samvera standpoint. It's pretty similar and somewhat inspired by the idea that Samvera is a community first and foremost. That said, Surfliner's goal is to build digital library products that are deeply shared. So this means that we use compatible infrastructure. We do continuous deployment to all the campuses that are using the products, and decisions that we make development decisions that we make are really tightly focused on being able to ship these services together. So we're very oriented around the idea that we're going to ship software. Part of the reason for Project Surfliner's existence is that both UC Santa Barbara and UC San Diego libraries had a sort of long-standing pattern of being able to do a lot of development and not necessarily get systems into production or carry them over the line to done. And we wanted to group up together to figure out how to not do that anymore and really make end-to-end service delivery the practice for both campuses. We do that in large part by selecting open source software that is close to what we need already and doing customization to make it shippable at both campuses. So we have a couple of products that are in production or close to it. Shoreline is our geospatial data services platform based on GeoBlacklight. And Starlight is our exhibits platform based on Spotlight. So you're seeing a theme. There's currently selection going on for what we're calling a staff-facing digital object management system. that will serve as sort of the backbone, the place where we make backbone architectural decisions about how to do long-term object storage lifecycle and preservation decisions, and that's being called Comet. And I can say with a little bit of a lens into the details that it's likely that that will be a Hyrax shaped thing. So that may also reflect some of the reflect on some of the details of my previous talk, and you can see sort of the motivations there. And then we also have a authority service called Lark, which heavily uses Valkyrie for its own architecture. It's not, this is totally homegrown. It's not even a Rails app, but it does use a lot of Samvera-ish infrastructure. So that's why we are here talking about Surfliner, is that we're closely wedded to the Samvera community. Yeah, so one of the things that we chose to do at the start of this project is to, again, really focus on DevOps practice and cloud native deployment. So that means we do 12-factor, which just, I'll skip revisiting the whole what is 12-factor thing. 12factor.net is the place to go to learn more. But what it means in practice for us and for the purposes of this talk is that we build one application and we deploy it to many environments. Those environments include, are separated along lines of like dev, staging, review, deploy, or production, etc. But they are also split along campus lines. So UCSB, for Surfliner's purposes, is an environment that we deploy Shoreline and Starlight into. Oh, and I forgot to mention the names are all historical trains. Surfliner is the train that runs between the two campuses, the current Amtrak train. 12-factor also means that we build applications for modern cloud deployments. We do that with Kubernetes. Each campus has a cluster and we deploy continuously to them. And then we build applications that are designed to scale. So that means that we want to be able to do horizontal scale out of our applications because we want to be able to build services that grow. 12-factor really means clean separation between the application and its environment. So environments vary, again, across deployment stage production, between campuses, and one of the strong opinions that we have is that we should be able to deploy our applications anywhere. We also follow an agile methodology. Our meetings are Scrum-like. We run 2-week sprints with combined daily stand-up across active products. I have to be careful about project versus product. So Shoreline, Starlight, Lark are products. Development teams are scheduled to work concurrently, and we're heavily invested in code review processes and pair programming, and part of that is building across the team. Okay, so that's Surfliner context. At the start of Project Surfliner, we made a choice, and that choice was perhaps made with limited knowledge in retrospect. The choice that we made was to use one Git repository for all of the Surfliner products. So that means that Shoreline, Lark, Starlight, various utility and scripts and shared dependencies that are locally developed are all living in one repository that everybody commits to together. This seemed like a really big choice to make at the time. And in retrospect, it really was, but then it also wasn't. So we have these shared products and development process that really is focused around everybody being able to work together. And the monorepo choice was one that we thought would enable us to move quickly and lower overhead for integration between systems. And that's more or less borne out. So a benefit that we got out of this is flexible code boundaries. If I'm working on code that impacts multiple products, then I can do those in one I can make those changes in one atomic commit. So for instance, if I've got a Ruby gem baked into 2 different Blacklight apps, then a change to that and a change to the dependencies that call it can all happen at once. Similarly, we can do lockstep releases. So we releases effectively for Surfliner are commits, and we continuously deploy. And anytime change happens to one system, we expect that to happen to all of them together. Similarly, the monorepo enables flexible team boundaries. So we have a shared build, test, and deploy pipeline that we all maintain together across the teams. Global code and code style and quality standards are in the repo, and testing integration between any of the products is easy because we can just build that into a pipeline stage, and so the effect is that any developer who's engaged in one product can relatively easily ramp up on another one, because all of the processes that are supporting development are centrally maintained. So these are benefits that we hoped to get and that are indeed realized. And I'm going to back up a second now and talk a little bit about places where this hurts or where we're growing. And I'll start with that it took us a little bit of relearning around dependency management. So this is, I guess, the other side of the coin about lockstep code changes, is that extracting shared services is really different than we're used to. So like once upon a time, we would make a Ruby gem and release it, and then coordinate releases of that gem with the versions that are in use, and or sorry, with the applications that depend on it. The dependency pattern that we use in Surfliner is a little bit more like developing inline dependencies, like we're just vendoring in all the code that we share. Yeah, you can think of it as like poly inlining, and that's a little bit complicated, just in terms of figuring out what the process should be for making those changes. I think this is one where this is a downside that we've sort of managed to handle pretty gracefully, but it was certainly like it felt twice as complicated the first couple of times that we were trying to extract something into something shared, where like before we would have had a pattern where you make a repo and put a Ruby gem in it and release that gem. And we can still release a Ruby gem, but in practice, we don't really do that because the actual dependencies that we ship in production are built from the monorepo to take advantage of the lockstep approach. So that's a sort of reconfiguration of our own thought processes about our dependencies that we had to do. Pipeline maintenance was something that also took us like a couple of times to get right. So we made a choice pretty early on to use GitLab, and the main reason for that was that at the time, this predates GitHub Actions, but at the time, we really felt like the GitLab CI pipelines were best in class. And particularly, we really needed them to be able to do the kinds of tightly configured pipeline configurations that we needed to do to support the monorepo. So our use case really involves being able to run builds depending on what code has changed. And it took us a while to get those configurations correct. So early on, knowing that the right build jobs were running for the right code changes was a little bit touch and go. It's really important if you're going to continuously deploy an application that that you are able to run the right kinds of quality assurance processes, automated quality assurance processes when you're doing that. So if like I make a change that breaks Lark and it doesn't run the correct build and test stage, but deploys the application, that's really bad. What happened was that it took us a little while to get the configuration really nailed down. One interesting thing is that these pipelines now require very little maintenance, and the pattern for cross-product configuration is really quite robust at this point. GitLab also kind of helped us by adding better support for our pipeline needs as time went on. So that led to a little bit of reworking of that pipeline configuration. But now we have directed acyclic graph pipeline dependency configuration. So that's the funny little chart that you're seeing here. There's a really specific now line of dependencies between jobs where they used to be very sequential. So these build stages that you see, build, test, integration, review, would be set up. They used to be set up in a way where everything in build had to finish running before test would run, and everything in test had to finish running before integration would run, and everything in integration before review that deploys a review app. For builds on the trunk, we also have staging and production stages that follow, and all of those things were sequential, and that meant that if I had one that ran slow, that everything was waiting. And they are sequential across products. So if one product's build is slow, then we'd be sitting around waiting for tests to run. The DAG configuration lets us make this really specific for which jobs depend on which other ones. So the build job is really necessary for the unit tests and the integration tests and the review deployments. but it turns out that the integration, the tests and the review deployments don't have a direct dependency. Like as soon as the build is done, I can deploy. And if the test fails, then I'll just knock down the deployment. So there's no need for us to wait for a long-running test suite to start also time-intensive deployment process. Instead, we can do those things in parallel. So that also gives us some configurability between contexts. So MR, or sorry, I'll spell things out. A merge request build can be a lot faster than a trunk pipeline, which is eventually going to deploy to production, and we want to be very deliberate and steady. So GitLab's really given us a lot of support there. Here's some of the actual pipelines that run. You can see that they vary quite a bit depending on right, like which jobs are being run is different depending on what's in the commits. Another place where we've had a little bit of pain is that there's some impact on outside collaborators. So the project looks big, and there is a lot of code in it. And if you're just stepping in and you're interested in deploying Starlight, the exhibits platform, then your entry point to Project Surfliner is really the whole project. There's multiple layers of READMEs to get down to the thing that you want to build if you're just building one product. Documentation in general has a high surface area. And perhaps most concretely, once you know where to go, developing on one application requires that you check out the whole Git repository. Or it doesn't strictly require that, but the kinds of solutions that would lead you to not having to do that are not the kinds of solutions that we want to ask low stakes collaborators to take on. If I want to fork the repo, running the pipelines and contributing MRs is pretty hard. And what we've done with collaborators so far is really onboarded them in general so that they have access to push branches directly to our shared monorepo. Permanently forking just one application would be a huge pain. And maybe that's a feature. In fact, I want to just like put a slightly different lens on this. So it looks like a lot of downside to have the project be so big, but it's also correct. Like this is a high touch communication project, and it's not really designed for contributions to be thrown over the fence. That has some downsides, but it's mostly okay with us. So yeah, that's the Surfliner monorepo. And I'm happy to take questions or discussion at this point.
I don't know how much time we have, but Anna asked a great question and I gave my perspective on it, but I thought maybe it would be good to get your perspective as well. I can't remember what our work cycle was before it was 60 days on, 60 days off. Do you remember?
I'm not sure that we had an explicit one. We started a 90-day work cycle the first time through.
Just to like kickstart.
And then I think later on we were like, okay, we actually need to be able to schedule this out across the campuses more predictably. So the 60 days on, 60 days off. A lot of choices that we make in Surfliner are designed to make decision-making overhead small. So it gives us a lot of predictability to just have a stable work cycle where we're either working together or explicitly not, and I can look ahead several quarters and make decisions about how to allocate my team's time on that basis.
And from just to add to that perspective, it also was really good for some of our subject matter experts that were going to be participating in the sprint to be able to tell them when they needed to allocate time towards the project. And that's usually not developers, but metadata people or geospatial people. Anna asked another question, and I already responded with my Pollyanna, so I think it's your turn to be anti-Pollyanna. I'm curious how these retros feel when you do them with the same team 3 work cycles in a row and repeatedly like that for 60 days. Does it enhance follow-up on things that come up, or does it get perfunctory?
I think I'm going to be Pollyanna about this too. I really like our retros. We use a tool called Retrium for the distributed retros that we love, and they're super useful every time. One thing that we're not always good about is follow up on actions for them, and that's a known issue. Is that some actions feel like Surfliner level actions, project level actions, and nobody really explicitly owns those because responsibilities are sort of split across teams. But we do our best to organize follow-up